Guys, in this video we are going to see operational amplifier as a summing amplifier. In this particular problem we are going to see how to calculate this VO in terms of input voltages. Now let's look at this one. When we deal with op amplifiers, we have to know two things. The voltage across the positive terminal is going to be equivalent to voltage across the negative terminal. Also, the current entering or exiting this positive negative terminal is going to be zero. Here we know that voltage across the positive terminal is going to be zero because this is connected to the ground. So this is zero voltage. So voltage across the positive is equal to zero. If the voltage across the positive is zero, then the voltage across the negative also going to be zero. And here you can see voltage across the negative and the point A, we don't have anything in between. So the voltage across the point A is going to be equivalent to voltage across the negative terminal. Therefore, we can say VA also equal to zero. Now we know this thing. Now to create the equation to find out the Vout voltage, we can apply Kirchhoff's current law at this node A. Okay. Now let's apply this one. So Kirchhoff's current law says all the current entering a node should be equal to the current exiting the node, or addition of all the currents should be equal to zero. Now let's try addition of all the currents equal to zero. Now here we have I1, I2, I3, I4. If we add them together, I1 plus I2 plus I3 plus I4, that must be equal to 0. Now I1 is going to be from here to here. Let's say this is V1. Let's say the whole thing is V1. Okay, let's say the first one is V1. Let's say this second one is V2. Let's say this third one is V3. So the first one is going to be V1 minus, if this voltage is VA, then the voltage here also VA, right? We don't have anything in between. So this also VA. So we can say V1 minus VA divided by R1 is equal to I1. So V1 minus VA divided by R1 plus I2 can be rewritten as V2 minus VA divided by R2. V2 minus VA divided by R2, and I3 can be written as V3 minus VA divided by R3, and we can write I4. We assume the I4 direction as this one. If we assume this direction, this is going to be VO minus VA divided by the resistance in between. That's going to be RF, or you can say R4. Let's write RF or R4. You can write both way, but it's better to write feedback resistance. Okay, let's write RF. So this is going to be VO minus VA divided by RF. That's equal to 0. Now we know that VA is equal to 0. We found out before, because voltage across the positive terminal is 0. Therefore voltage across the negative terminal also 0. If the negative terminal is 0, then VA also 0. So VA is 0. So we can write this equation in a simpler way, like V1 over R1 plus V2 over R2 plus V3 over R3 plus VO over RF, that's equal to 0. Here we are trying to find VO, so let's move this VO over RF to the other side of this equation. If we bring this to the other side of the equation, that's going to become, let's continue this one right here, V1 over R1 plus V2 over R2 plus V3 over R3 is going to be equivalent to negative VO divided by RF. Now we only need VO, right? We are trying to find VO. So VO is going to be, let's move this negative sign and this RF to the other side of this equation. So this is going to become VO is equal to negative RF times V1 over R1 plus V2 over R2 plus V3 over R3, and this is going to be the final answer. Also we can express this one, we can multiply everything by RF. If we multiply, let's get rid of this part, let's get rid of these parts and write our final answer. Okay, so if we multiply everything by RF, we are going to have VO is equal to negative RF over R1 divided RF over R1 multiplied by V1 plus RF over R2 multiplied by V2 plus RF over R3 multiplied by V3, and that's gonna be the final answer. And that's how we do this kind of problems. I hope this helps. Thanks for watching.